Matrices and systems of linear equations. All right, to start off, here are your state standards and your success criteria. To be successful, you need to be able to write an augmented matrix, perform elementary row operations on matrices, use matrices to solve systems of equations, including those involving real-life context. Here's your key vocabulary terms: an augmented matrix. You can represent a system of equations using an augmented matrix. In an augmented matrix, each row represents one equation. The columns represent the coefficients and the constants. All right, so here's a picture of a system of equations. So if you have a system of equations, this is equation 1, this is equation 2, and you can see that they put the coefficients and the dots represent an equal sign, and then your constants go on the right-hand side. A coefficient matrix, the matrix consisting of only the coefficients, so that would be this matrix here. Row equivalent, when their corresponding systems have the same solution. And row echelon form, when the coefficient matrix consists of ones along the main diagonals and zeros below the main diagonal. You can see here's ones along the main diagonal, a 0 here. So there's some constant term, and these are just numbers as well. So M and M represents numbers. Example 1, writing an augmented matrix. All right, so we're going to write an augmented matrix from the system of linear equations. All right, so this is a little different than what I've done in the past. Typically, we have different matrices, but they're using an augmented matrix. So we're going to put all the information in one matrix. So I'm going to put the coefficients. So I've got 3, -1. When it has a negative sign, that's assumed to be -1. And there's no numbers in front of these variables. So again, you assume those to be a 1. All right, with the augmented matrix, you're just going to have the dotted line down the middle, kind of separates the coefficients from the constant terms. So that dashed line just represents your equal sign. All right, and then we have 10 and 6 here. So when it says to write an augmented matrix, that's all you have to do. Pull out your coefficients and your constant terms and put it in matrix form. All right, same thing for B part. We're going to have 1, -1, 2. That's our constants from our first equation. Then we're going to have 2, 1, and 0. There's no z, so it represents a 0. So 2, 1, 0. And then the last equation, 4, -3, 1. And then our dashed line represents our equal sign. And then our constants go on the right. So 2, 0, and 1. All right, so this is called an augmented matrix. All right, example 2, solving systems of linear equations. So it says solve the system of linear equations using augmented matrices. Now, we have solved systems of equations by graphing, by substitution, by elimination, and now you're learning another way, which is matrices. Now, being able to write this as an augmented matrix, that's fine, but I'm going to show you an easier way to do this on your calculator. So here's the process of using an augmented matrix to solve this system of equations. So they first write it as an augmented matrix, and then they take the first row plus -2 times the second row. So the first row is 4. 4 plus -2 times 2 would be -4. 4 plus -4 is 0. And then row 1, so 3 plus -2 times -1 is +2. 3 plus 2 is 5. Row 1, 14, plus -2 times -8 is +16. 14 and 16 give me 30. So this row came from doing row 1 plus -2 times row 2. All right, so using augmented matrices, they are wanting you to then multiply row 2 by 1/5, then multiply row 1 by 1/4, and then at that point, this gives you your x and your y. It's saying because this is 0 and 1, this is your y value. But you still have to take that y value and plug it into the first row to get x. So after all of that, you get negative 1 6. All right, so I want you to see this, but where I'm not going to show you, there's a much easier way to do this using your calculator. So here we go. It does say you can use technology, so we are going to use technology. Hopefully you have a TI-84 and you can follow along. All right, so there is here in blue, it says matrix. So if you go second matrix, and we're going to go over to edit. All right, so matrix A, we're going to call this left side, the coefficients, matrix A. So we're going to say matrix A is a 2 by 2. All right, so that's going to be 4, 3, 2, and negative 1. So we're going to do 4, 3, 2, and negative 1. All right, so we're going to call that matrix A. Then we're going to go second quit, and that saves matrix A in there. So again, this is matrix A right here. Let's write that down. So A is 4, 3, 2, negative 1. All right, then we have our variables, x and y. And then we have our constants, 14 and negative 8. All right, so just slightly different than the augmented matrix. All right, so I've already entered A. Let's call this matrix, our constants, matrix B. So scroll down and go over to edit. Make sure it's on matrix B. So edit matrix B. And this one is 2 rows by 1 column. So this one is a 2 by 1. You do have to be able to put the dimensions in there. And then 14 and negative 8. All right, and then second quit. And this is very simple. So this is matrix A. This is matrix B. If we do A inverse times B, that equals x, y. All right, so this is something I would make sure you are well aware of. And we're going to talk about this a little bit more. But if you go second matrix, this time we're not going to edit. We're just going to choose matrix A. Here's your inverse button, x to the negative 1. That gives you your inverse button here. And then times matrix B. And negative 1, 6. Negative 1, 6, you can see is the answer here. They did it the long way. And you can use your calculator to say x equals negative, what was it? Negative 1 and 6. All right, so that would be the ordered pair. That would be the solution of this system. If you graph this line and you graph this line, you would see the intersection point here. If you use substitution, elimination, or matrices, you will also get the same answer if you do it correctly. All right, so this is some more important information. This is, a lot of this is from a previous class. I want you to kind of understand why you do the A inverse B. So multiplicative identity. Again, these are your identity matrices. We talked about that in the last lesson. But there's something called the determinant. All right, that's not in your state standards, but you can find the determinant. This is something you may see on the ACT. It may say find the determinant of a 2 by 2. There is a determinant button in your calculator, but you can easily do that by doing AD minus BC. All right, and the determinant is what's helpful in finding the inverse. So when you want to find an inverse of a 2 by 2 matrix, this is what would happen. So the inverse allows you to solve an equation. So basically when we're solving an equation, if we have x plus 2 equals 4, we subtract 2 from both sides because that's the inverse operation. Well, with matrices, this is allowing us to do the inverse operation, which is allowing us to solve easily and quickly using our calculators. So be aware, You don't have to know the determinant or anything about it. Just be aware that this is the process you go through if you did it by hand. All right, so using your calculator, if you want to solve a matrix equation, this is the steps, this is the process that you're going to use. I would put this in my notes. Make sure you have these steps in your notes so that you know how to find the solution using a calculator if you want to solve a matrix equation or a system of equations using matrices. And you can see here, if you have the matrix, order does matter. Order does matter. It has to be A inverse times B. All right, so just to practice, I want you to take a couple minutes and look at this. This is how you do this using your TI-84. So we have a matrix, or we have a system of equations, I should say. It's a 3 by 3, 1, 2, 2. You can see here 1, 2, 2, 3, negative 2, 1, 3, 2, 1. That should have been a negative 2. Let's add a negative here. And then 2, 1, negative 1. And then x, y, z, 5, negative 6, negative 1. All right, so I did lose a couple negatives when I was making the matrix here. So go ahead and make sure these negatives are included. Again, that comes from right here in the equation. All right, then you're going to call this matrix A. You're going to call this matrix B. And you're going to find x, y, z by doing A inverse B. So let's go ahead and do that. I'll go through one more example with you. All right, we're going to edit matrix A. This time matrix A is a 3 by 3, so we're going to change that to a 3 by 3. And then we're going to have 1, and I'm just going to put these numbers in over top of the numbers that were there. You see it goes across the rows and then it comes down to the next row. So 3, make sure that is a negative 2 and a 1. And then I'm going to put in 2. This is a little easier and quicker if you use a handheld calculator. So second quit, that saves the matrix in there. I'm going to go second matrix again. I'm going to go over to edit, and this time I want to edit B matrix. All right, my B matrix comes from my constant terms, 5, negative 6, 1. So that is going to be a 3 by 1 now. So make sure you change the dimensions. And then that's going to be 5, negative 6, negative 1. All right, and then I'm going to do second quit. That saves my B matrix in here, and then I'm going to do matrix. This time I'm going to choose A, inverse, nope. Matrix A, inverse button, matrix B. Remember, you've already got the matrix information in there. The elements were saved in there. So now it will solve negative 1, 2, 1. So that would be negative 1, 2, 1. That would be your X would be the first one, Y would be the second one, and Z would be the third one. So again, you can solve these by graphing, substitution, elimination. Now you can solve these with matrices. All right, take just a moment, do the self-assessment, and we'll check our answers in a second. All right, hopefully you took a couple minutes to enter matrix A and B in your calculator. Then if you did A inverse B, you will get negative 2, negative 3, and 3. So this would be your X, your Y, and your Z. So negative 2, negative 3, and 3. Again, you can do it the other way using the augmented matrix, but the calculator is much quicker.